ओके। तो वही कैसे हो, चलो देखते हैं सेकंड क्वेश्चन का अपना एक्सप्लेनेशन। सो what is the question? We are given nums and an integer k. We have given k units of resources. Okay, you must process the element of num side. You have to process the elements from left to right. Okay, so we need nums of I resources to process an element. Okay, so if we are at element x, we need at least, right, x resources. Okay. After processing the ith element, your available resources decrease by nums of I. Okay. What is the cost? The value of k is fixed and does not change. Okay. The first such operation cost 1. Second incurs a cost of 2. Okay. So with every operation, right, cost increases. Cost increase with each operation. Okay. And we have to return the minimum total cost. Okay. So, right, we can do a simple greedy simulation here. So, in the end, I'm going to tell you a trick as well. So while solving this in the contest, that did not come to my mind, but in the end, I will show you trick. That's not a trick. That's a very, what do you say, very smart approach to solve this question. So what does grid emulsion mean there, right? So that's basically simple thing, right? So we initially we have number of operations 0. So tell me if in the end, right, I am at I have done total ops or number of operations, then what is my cost? Right, 1 plus 2 plus till ops, right? So what will be my answer? Right, ops multiply by, right, ops plus 1 divided by 2. That is right. But sum of arithmetic series, you should know this one. If you don't know this one, I mean, एक बार 10th 12th का मैथ्स का बुक देख लेना, बट ये सब पता होना चाहिए. ओके. सो राइट, नंबर ऑफ ऑपरेशंस इक्वल्स टू 0 at any point, right? We'll say I have initially resources equals to k, right? I'll start, right, 4 equals to I to 0 till n. I'll go. What I will do? Okay, what I'm going to do, right? Current element is what? My nums of I. So I'll simply check, right? If nums of I, right, is this less than my, right, resources? If it's less than resources, then what I'm going to do? We simply do, right, resources minus equals to nums of I. We basically simply remove this one. Okay, and if it's not, what we are going to do? Let's say we have 1 2 4, right, and then we have 8. K equals to 4, right? We start with, right, initially 4 resources. We have resources 4 left. After each operation, right, we are left with 3. What is the number of resources here, right? 3. We are left with what? 1. Can we complete this one? No. So what we are going to do? We are going to add k, right? 1 plus k, that is right. What it will become, right? 5. Can I do it? 1? Yes, I can do it, right? What is left? 1, right? Now again, so is this less than 8, right? So 1 less than 8, right? Yes. So how many can I do it with adding one operation, right? It is 5. Is 5 less than 8? Yes. So I have to add again plus 4, right? Which is 9, which is greater than 8. So what it will become, right? 1 plus 4 plus 4, right? The number of left is 1. So how many total operations I did? 1 here, 2 here, right? Operation equals to 3. So at each element, right, we check if it's greater. If it's not, how many we need to add, right? How many we need to how many we need to add? Okay, so what we are going to do, right? We are going to do a needed equals to what, right? Nums of I minus what do I have till now, right? Okay, so how many operations are required, right? Right, how many operations are required here? Operation required means basically how many times I have to increase k, right? So what I'm going to do, right? Needed divided by k, and I'm going to take the upper bound of this one. What? Let's say if it's 9, right? If I say 9 modulus 4, right? Sorry, 9 divided by 4, what it will come 2, right? But there is one more resource left, right? So we'll take it 3, right? The seal value. Okay. And then we update our resources, right? Minus equals to what? Resources plus equals to what, right? The operations we did, we multiply it by k, right? And what do we separate? We subtract the current element. And in the end, what do we return, right? We add it to the ops, right? Ops plus equals to operations. Here, what do we return, right? Ops into ops plus 1 by 2. So this is op and solution. Now, now you tell me a question, right? Tip, trick, say, smart solution. Now you tell me one thing, right? What we are actually checking, right? We check if each n, right? Each nums of I greater than k, right? If it's not, we increase, right? Resources, right? We increase the resources by plus k. So, right, since we check for every element, can I do like, right? So let me say it like this, okay? Right? This is x1, right? If it's less than resources, we do nothing. So then tell me, what is the value of x1 divided by k? 0? Okay. So if x1 greater than resources, what do we do, right? We increase. How much we increase, right? Till it becomes, right, greater than k, right? So can I say x1 divided by resources, right? Minus, sorry, what is the required, right? X1 minus resources upon k. Can I say this one, right? The seal value of this one, right? That's okay. The seal sign is, I think, above side. Can I say this one? Okay. So for, right, for x1 to till xn, what is my final answer, right? X1 by k plus x1 minus response by k plus and so on, right? So what is this thing, right? Sum of x1 till, right, xn divided by what? K, and the seal value, right? This is number of operations effectively. So what I can do, right? Operations, right? Sum of nums divided by k, take cell, and again the answer equals to what? Ops into, right? Ops plus 1 by 2. This is the answer. Take proper modulo, right? Since this numbers, right, the range is till 10 raised to power 5 k, nums of I less than equals to 10 raised to power 9. So, right, take modulo everywhere. K, thank you. That is minimum number of minimum total cost to process all elements. We have given a nums of integer k, right, unit of resource. Okay, you must process the element of nums from left to right. Okay, we have to loop to process ith element. You need nums of I resource. Okay, if your available resources are less than nums of, you may perform, right, and increase your available operations by k. Right, if available resource, right, less than k, increase it by plus equals to k, and this is going to add cost plus plus, right, return to the minimum total cost operations plus plus actually, right. Second incurs a cost of 2, and final cost will be what? Final cost equals to what? 1 plus 2 plus till operations, right? We have to take modulo as well, so mod equals to, right, 1 in 9 plus 7, so we'll take everything long, right? Long operation 0, long, right? Finally is answer, right? That's fine. long answer equals to, let's say, then what do I need, right? I need the current something to hold the current resource, right? Resource count. And the long count equals to, initially I'll start with k, right? From left to right I have to do, right? From left to right, 4 and right, plus plus, right? N is what, nums dot size, right? And the current element equals to what, nums of I, right? What I will check, right? If current greater than count, right? If current less than count, right? What do we do? Count minus equals to current, right? Continue. We don't need any operations, right? Now what? Uh, so right, required difference, right? So we'll do long required equals to what? What is my current minus what do I have? Count. So how many operations will it write? Required divided by k. 4 plus 4, right? Let's say 4 plus 4 plus current is 2, which is equals to what, 10, and required is 11. Then okay, we also check the modulo, right? If what, require modulus, right? K not equals to 0, we do operation plus plus, so total equals to now. So what we are doing, right? Operations, right? Oops, plus equals to what? Operation. And what is my new count value? New count value is right? Number of operations multiply by what? No, sorry. Number of operations is what I did. Right? Operations multiply by k minus current element. Okay. Final cause this is right. Answer equals to what, right? Operation into, right? Operation plus 1 divided by return answer, right? We have to take mode now, so we'll take mode here as well. So we'll take mode at lot of places, I think. Right. So operation into k, right? Count minus equals to current, right? So that it will not becomes negative. Oops, count, can it become, don't know, let it be. Expected long, okay. Long answer equals to 0 count, right? Operation and identify. So we do, right? Oops. Number of operators. First was expecting 3, second was expecting 21. This is wrong, second is wrong. Third is fine, second is wrong. Why do we have it wrong, right? Current nums of I, if current less than count. What do we do? Count minus equals to current, right? Continue. First is less than equals to will also work, right? Okay. Required equals to what? Current minus count. Operation equals to required by k, right? If required modulus k not equals to 0, we need one more operation, right? Operations we add, oh, we do count minus equals to, right? Modulus k. This seems correct here. So what happened is, right, count here equals to 0, right? Then I dot count plus equals to, I do, right, k. I increase, right? Operations plus plus will do if count greater than 1. Current count minus, right, minus same condition, right? So for use test case should give us output 6 expected 36. Where do we are wrong? Mm, am I missing something? I'm sorry. Specify the value of k is fixed, k less current, right? Current element less than count. Am I missing something? For I 0, I less than unstored size current, right? Count, if count is 0, we increase count by k, we do operations plus plus. If count greater than current, we count minus and we do continue. Okay. Required is what? Current minus count. Required by k because it increase in the steps of k. This is right. And if required modulus k, we will increase the by 1. Right? Operations plus equals to 1. What is the new value of count? Count will become, right, operations multiply by k, right? Yes. What is the current value of count plus operations multiply by k minus current element? Right, output 36. Now it's fine. Now I think we have to do modulus, right? We'll try hit submit. Integer overflow. This we cannot do simply, right? So operation equals to, right, oops plus 1% is small. This is fine, right? Small. It will definitely greater than, right, this thing, right? Percentage of mod run 630. We don't know. It's not integer overflow. Wrong answer. Output 6 expected 3. Hmm. What do we have here? This right count plus operation multiply by, okay, 3 only. I think this value is becoming wrong somehow. Output 3. Right, this current can be negative. Okay, this is accepted. This thing is wrong.